So today we are going to be finishing chapter 11. So this will put us one chapter away from the end of the year. It's coming up quick on us, guys. So we're going to learn how to now take these rational expressions that we've been simplifying, and now we're going to be able to create equations with them and solve these equations. So now these are the questions that we're going to be getting, like x is equal to 5 or y is equal to 3. So we're going to be solving equations now. So let's say I had a simple equation like this. Let's say I had 3 over x plus 5 is equal to 2 over x. Okay? So if we have a simple rational equation like this, the first thing that we need to look at is the fact that this is a fraction that equals a fraction, a single fraction that equals another single fraction. If we're ever given this concept here where we have one fraction on each side of the equation, well, we should already know what to do in order to solve this type of problem. If you remember back in, I think it was chapter 4 or 5, we learned how to solve a proportion, which was a fraction equaling another fraction. Well, that's exactly what this is. This is essentially a proportion. So what I'm going to do in order to solve this, and again, this only works if you have a single fraction on both sides of the equation, you are able to cross multiply. So I'm going to take the numerator here and multiply it by the denominator here. So 3 times x, that's going to give me 3x. Then equals the denominator here times the numerator here, x plus 5 times 2. Remember, when I'm multiplying this by 2, I have to multiply all the terms by 2. So this is going to be 2 times x, which is 2x, and plus, and then 2 times 5, which is 10. Well, now I get to go and just solve this like a normal algebraic problem that we've been doing all year. Get the x's to one side, so subtract 2x from both sides. So I end up with x equals 10, and then that would be my answer. I have the x by itself. But now with all of these rational equations, we have to make sure we check our answer, and it's very important. All right? We've gone through the year, and there have been a lot of problems where I've said you don't really have to check it. It's nice to check if you want to get the correct answer. But there have also been certain problems that I said you have to check the answer because it might be wrong. Even though you got the correct number, this number might not work. Especially in rational equations, you have to check your answer. All right, we have to remember we're working with a fraction. And in the denominator is the variable. And we know that this denominator cannot be 0. So I may have gotten an answer that makes the denominator 0. I have to check that. So I have to take the x and I have to plug it back in and make sure that I get something that makes sense. So I have to check this. So on the side here, we do our check. I take the x and I plug it in. So I have 3 over 10 plus 5. I'm going to replace the x with 10 equals 2 over 10. And now I don't cross multiply or anything. All I'm going to do here is simplify this as much as possible and see if I get the same thing on both sides. So 10 plus 5, that gives me 15. 2 over 10, that actually simplifies down to 1/5. 3 over 15, that's going to simplify to 1/5. And as we see, we get the same thing on both sides of the equation. So that means that this answer is the correct answer. I'm able to use that as my correct answer. So again, it's very important to actually check our answers here. If we don't check the answers, then there is a possibility that the answer that we're putting is not the correct one. All right, so I've put 2 problems here up on the screen. I'd like you to pause the video, take about 5 minutes, try these on your own. Remember, we are working with a single fraction equaling another single fraction, so we should be able to just cross multiply these. And then once we cross multiply it, solve it, and make sure you check your answer. So take about 5 minutes and do these. Okay, so here are our two answers. So the first one, we see that we cross multiplied here. 7 times y plus 1 is 7y plus 7. Remember, you have to take the 7 and multiply it by both the y and the 1. Equals y minus 3 times 3 is 3y minus 9. Now I solve it like a normal algebraic expression. Subtract the 3y from both sides. We get 4y plus 7 equals negative 9. Subtract the 7 from both sides. We get 4y equals negative 16. Divide both sides by 4. We get y equals negative 4. Then I go and I check it. I plug in the negative 4. Negative 4 minus 3 is negative 7. Negative 4 plus 1 is negative 3. 7 over negative 7 is negative 1. 3 over negative 3 is negative 1, so we know that this checks out. Same thing for the second one. Cross multiply. We get 91 equals 20f plus 2. Subtract the 2 from both sides. We get 89 equals 20f. Divide both sides by 20. And we get f equals 4.45. Yes, you can get decimals here, guys. It's fine. Remember, though, if this was something that could have been simplified easier, I would suggest simplifying it. But if not, you can write it as a fraction. Not a big deal. But now when I go and check it, it does make it a little more interesting. I plug in the 4.45 here. 2 times 4.45 is 8.9. 8.9 plus is 0.2 is 9.1. Now here, there's no real way that I could have checked that these two fractions are equivalent, because I can't really break this down. So all I did was I said, all right, well, what is 13 divided by 10 as a decimal? That's 1.3. What is 9.1 divided by 7? That's 1.3. So if you're not sure about whether the two fractions are equivalent or similar, you can always divide numerator divided by denominator, write it as a decimal, and see if the decimals are the same. Because remember, you can always convert from a fraction to a decimal, no problem. All right, so let's try a problem like this then. Now that we know how to do it if it's just a fraction on one side and a fraction on the other side, let's try a different one. Let's try one where we have fractions on one side plus, addition, subtraction, all that stuff. We'll make it a little bit more complicated. So here we want to do 4 over y plus 5y over y plus 1 equals 5. Well, if this is the case, we're going to take this and do two different steps to it. The first thing we're going to notice is that the denominators on the left-hand side of my equation here are different. Now, if we think back to the previous lesson, when we have different denominators, we needed to get them to be the same. So that's what we have to do first. So what I need to do is I need to find the least common denominator, the LCD, or the least common multiple of my denominators to first work with that. So I need to find the LCD, the least common denominator. Now, hopefully we remember how to do that. If not, go back to the previous video and watch that. That'll show you how to find the least common denominator if your denominators are not like. In the case of the one that we have here, again, we're going to do this quick because hopefully we understand how to do this. The least common denominator between y and y plus 1, that's going to be y times y plus 1. So that needs to be the first step that we do. Now, in the previous lesson, what we would do is we would take this least common denominator, we would make each of my denominators that denominator, and then we would multiply the tops and then add them and do all that. Well, the good thing is when we have an equation, we can actually skip a couple steps and kind of push things into one here. So the second step, all that I'm going to do is I'm going to multiply each side of my equation by the least common denominator. So again, I'm going to multiply both sides by the least common denominator. All right, so what I'm going to do is I'm going to multiply this side here by my least common denominator of y times y plus 1. And I'm going to multiply this side here by y times y plus 1. So I'm going to multiply both sides by that least common denominator. Now, when we do that, we do have to make sure that we're a little bit cautious with this, because when I multiply this entire side by y times y plus 1, I have to multiply both different fractions. I have to multiply both terms. So what that means is for the first one, I'm going to be multiplying y times y plus 1 times 4 over y. Okay, now let's just take a look at this and see how I can work with this. Well, hopefully we remember how to multiply fractions, right? We would take the y times y plus 1. We would put that over 1, and then we can just multiply straight across, right? So we would do y times y plus 1 times 4. We would do 1 times y, but we should notice here that I can cancel something out. I can cancel those y's out, right? If I have something that can be simplified, I want to simplify it. Definitely simplify first, okay? So now that we have these y's canceled out, now it makes it a lot easier, because y plus 1 is the only thing left here, 4 is the only thing left here, and y plus 1 times 4, that's just going to be 4y plus 4. Alright, so I'm going to leave that here. We've multiplied this y times y plus 1 by the first fraction. We're now going to do it to the second one. So this is going to be y times y plus 1 times 5y over y plus 1. And I'm going to do the exact same thing. I'm going to put the y over, times y plus 1 over 1. I should recognize here that I see a y plus 1 on top and a y plus 1 on bottom, so those two will get canceled out. And now on top I have y times 5y, which is 5y squared. Now I'm going to go to the other side of the equation, and I'm going to do 5 times y plus 1. So it doesn't matter in which case or in which way I multiply these. I could do the 5 times y first and then multiply that by y plus 1. I could do the y times it first and then multiply it by 5. It doesn't really matter. We'll do the 5 first. 5 times y is 5y. And then I have to multiply that by y plus 1. So 5y times y is 5y squared. And 5y times 1 is 5y. And now I'm left with an equation that does not have any fractions in it. Now I get to solve this just like a normal equation. Get all the variables on one side, get all the numbers on the other. So I'm going to subtract 5y squared from both sides. And would you look at that? They cancel each other out, right? 5y squared minus 5y squared is 0. 5y squared minus 5y squared is 0. So I'm left now with 4y plus 4 equals 5y. I'm going to subtract the 4y from both sides. And I'm left with 4 is equal to y, or y is equal to 4. But again, because we're working with rational expressions, I need to check my answer. Check that y equals 4 even works, right? If I don't check that works, then I'm not even sure that that is the correct answer. So let's take a look. If I take this and I plug the 4 back in for all of my y's, let's see what we would get, see if it makes sense. So I'm going to have 4 over 4 plus 5 times 4 over 4 plus 1, and will that equal 5? Well, let's see. 4 over 4 is 1. 5 times 4 is 20. 4 plus 1 is 5. 20 over 5 is going to simplify down to 4. And 1 plus 4 does equal 5. So this checks out. My answer is going to be y equals 4. Alright, so you have two problems here up on the screen. I would like you to pause the video, take about 5 minutes, and try these on your own. Remember, step 1, find the least common denominator. All right, and that's the least common denominator throughout the entire equation. All right, not just the one side. You have to go throughout the entire equation. Then step 2, multiply both sides by that least common denominator. Okay, and then you should be left with a nice simple algebraic equation that you can solve no problem. So again, take 5 minutes, do these two, and then come back, unpause it, and see if you got them correct. All right, so I know there's a lot on the screen. You have to understand that these are a little bit longer of problems. Not that they're harder, they just take up a little more space. You're multiplying a bunch of fractions by a big parenthesis here. So, don't get overwhelmed by the amount of work you see on the screen right now. But for the first one, like I said, step 1 is to find the least common denominator. The least common denominator here is going to be b minus 2, b plus 2. So I'm going to take both sides and I'm going to multiply it by b minus 2, b plus 2. When I multiply the first fraction by b minus 2, b plus 2, the two b minus 2's are going to cancel each other out. So I'm just going to have b plus 2 times 2b minus 5. We have to double distribute that. b times 2b is 2b squared. b times negative 5 is negative 5b. 2 times 2b is 4b, and then negative 5b plus 4b is negative b, and then 2 times negative 5 is negative 10. Then it's the next one, 2. So I have to multiply 2 times b minus 2b plus 2. So I want to multiply those together. b times b is b squared. b times 2 is 2b. Negative 2 times b is negative 2b, so those two cancel each other out. 2 times negative 2 is negative 4. And then I have to multiply that by 2. So that's going to give us negative 2b squared plus 8. Then I do the same thing on this side. Multiply it. I see that the b plus 2 on top and bottom will cancel. So it's 3 times b minus 2, which is 3b minus 2. Now I can start combining and simplifying. I see a 2b squared and a negative 2b squared. Since they're on the same side, they cancel each other out. I have a negative b, so that's going to stay. I have a negative 10 and a positive 8. That's going to become a negative 2. Now I solve this. The 3b minus 2, nothing happens to it. I'm going to add the b to both sides. I get 4b. I'm going to add 2 to both sides. I get 4. And sorry, this should not say 4. This should be b is equal to 1. When you divide both sides by 4, you get b is equal to 1. Now, I know it's not shown on the screen, but that's because I didn't have a lot of room, but you should always check yourself. When I take this 1 and I plug it in, 2 times 1 is 2 minus 5. That's going to give us negative 3. 1 minus 2 is negative 1. Negative 3 over negative 1 is a positive 3. And then 3 minus 2 would give us 1. Going over here, 1 plus 2 is 3. 3 over 3 is 1. So I do have 1 is equal to 1. So both sides work out nicely. Then I move on to the next problem. Same thing, but now as you see on the denominators here, I didn't work with 3n plus 6 and 5n plus 10. What I actually did was I factored those. I made it a little easier. So instead of working with 3n plus 6, I did 3 times n plus 2 because I factored out of 3. Here I factored out of 5. Now the reason this made it easier was because, look, they have an n plus 2 in common. That's part of my least common denominator. Then all I have to look at is the 3, the 5, and the 5. Well, the least common multiple between 3 and 5 is 15. So my least common denominator is 15n plus 2. If you didn't do it this way, it would be a lot bigger numbers. You'd be working with a lot of bigger numbers in the numerator here. This actually makes it nice and simple. So now I'm going to multiply both sides by 15n plus 2. When I multiply this by 15n plus 2, look, the n plus 2's now cancel out. The 15 and the 3, they'll simplify to be a 5 and a 1, and on top I'm left with just 5n. Same thing, excuse me, same thing over here. The n plus 2's cancel out. The 15 and the 5 simplify to a 3 and a 1. So I'm left with 3n on top. So it's 5n minus 3n. On the other side here, the 15 and the 5, again, simplify out. This becomes a 1, this becomes a 3. 2 times 3 is 6, and then 6 times n plus 2, that's going to give me 6n plus 12. Now I'm going to go and I'm going to solve this. And when I solve this, I end up with n equals negative 3. And again, I should check it, but in lieu of space and time, this is the correct answer, I promise you. All right, so the last thing we're going to do here is a very similar problem to the one that we were just working with, but you're probably continuously saying to yourself, I don't want to check my answers. I really don't. It takes time. I don't need to be taking more time than I need to. But here's the reason why we have to check our answers. So let's say we had the problem 2n over n minus 5 plus 4n minus 30 over n minus 5 is equal to 5. So let's say that this is the problem that we had, and we're looking to solve for n here. All right, well, we already know what we have to do here. My first step is to find the least common denominator. Well, that's a simple one because they're both n minus 5 here, and this is a 1, obviously. So my least common denominator here is n minus 5. That's great. That makes it really easy for us. Because when I go and I multiply both sides by n minus 5, when I multiply this here by n minus 5, the n minus 5s will cancel out and I'll be left with just 2n. When I multiply this by n minus 5, the numerator here and the denominator here will cancel out and I'm left with 4n minus 30. So nice and easy on that side. Over here, I just do 5 times n minus 5, and I get 5n minus 25. Okay. Now I just go about solving it. 2n plus 4n, that's 6n. So I have 6n minus 30 equals 5n minus 25. Subtract the 5n from both sides. I'm left with n minus 30 equals negative 25. I'm going to add the 30 to both sides, and I get n is equal to 5. But now the problem here is if you stopped right here and said that your answer is n equals 5, you would be wrong. Because if I go back and I do my check and I plug this in, I'm going to have 2 times 5 over 5 minus 5 plus 4 times 5 minus 30 over 5 minus 5 equals 5. And right away you should recognize something. My denominator, 5 minus 5, that's going to end up being 0 on both of these. But we already know that we are never allowed to have a denominator that is 0. So in the case of this, 5 is not really my answer. So this problem actually has no solutions. We call this, and we've talked about it before, this is what we call an extraneous solution. Again, an extraneous solution is one that when you actually solve it mathematically, you get an answer, but that answer does not work in the problem that we had. Okay, so in this case, yes, when we solve it, 5 is the answer we get. But when we actually try to plug it back in, we can't use it because it makes our denominator 0. So n equals 5, that's an extraneous solution. Okay, so this is the reason that we check, because we could get an extraneous solution. All right, so always check your answers.